Hello guys, let's understand the binary search and its implementation. So let me first tell you about the binary search. Binary search is a divide and conquer algorithm, and it repeatedly divides the array intervals in the half, and it is only effective for the ordered elements like sorted arrays. So now let's do its implementation. Now let's take a variable and take the found index. We will get the index of the element which we are looking. So we will search for an element in this array, and this function will return the index. So now let's name it binary search, and we will binary search takes two arguments, first array and the target generally which we are looking in the array. Now we want to search for 99. So now here we will do console if we found the element index. Now found index, if the index is found, that means we found the element, so we can directly get the element array dot index simply if we found the index. Now let's do its implementation. It's very easy, and I will try to make sure that it will fit in your brain. Now here write the function, and here take the arguments like array and the target here. So first thing what you have to do, you need to define the variables like left and right variables and the mid variable. Like as I said, it repeatedly divides the array intervals in the half until you find out the element. You may find out the element at the mid directly, and in that case your time complexity could be 1 constant. If the element is not at the mid, our time complexity will be log n. The best case is 1 and the worst case is log n. Similarly here we will declare few variables left, right, mid, so its space complexity is also constant generally. Now let's understand it. So we will use iterative approach. We are not using any recursive approach here. So left will be your index 0, and your right will be your array dot length -1. This is your right, and the mid, so we will use the mid within the loop. Now let's write the while loop, and here we will use left less than or equal to right. So this is the condition. It will continue iterate until the left is less than or equal to right. Now here we will define our mid. So our mid will change on each iteration. Yeah, so now how will we calculate the mid? We'll take its floor value. So we'll use math function math dot floor. It will be our integer, and we will do sum here, left plus right, and divided by 2. So you will get the integer value in the mid. And now here we will write the logic. Here first we will check the values at the mid directly. Now here if the value is here, in that case what we will do, we will just return the mid. That means we found the element. So this is the case like when the time complexity is constant. Now just return the mid. Now there is else if condition. Here there is else if. In the else if, now check whether the target is less than the value at the mid. Now we will check if the target is less than the value at mid. So in that case your right will be shifted to the mid. So your right will be mid -1. And there is else case when the target is greater than the mid value. In that case your left will be shifted to the right. Left equal to left plus 1, mid plus 1. Simple. Now here is one more case when you are passing empty array, or when the element is missing in the array. Your while loop won't return anything. In that case you will have you need to return -1. So you can return here -1. So now let's check it. Now you can see, let's run it. So it is saying ri is not defined, so there is something missing. ri, where is this? Right is there. So this is the right. Now let's see the output. Here we go. So this is saying a 99 is at the index 3. If you see 0, 1, 2 and 3, 99 is at index 3. Now if you pass nothing in the array, then what will be your output? It should be -1. That's why it is giving. That means you didn't, 99 is missing in the array. That is what it is returning. Now if you see the length of the array could be n. If the length of the array is increasing, a binary search complexity will also increase. So I told you there are 3 cases when the element is present at the end of the array or at the beginning of the array. In that case, your complexity best and worst is going to be log n. And when the element is present at the mid, this is the just one comparison. So your time complexity is going to be constant. Let's suppose, if you can suppose there is a log n, and here in the log if there is 16. So if you see the log 16, that means there are 16 iteration. Sorry, if the size of the array is 16, suppose here are few elements. If I am saying there are 16 elements in this array, so though your complexity will be log 16. Log n means log 16, and the comparison will be log 16 is equal to 4. So your comparison, there are 4 comparisons which will happen in that case. Yeah, this is it. Now you can understand it. So this is the binary search. I hope you guys have understood it. If you like this video, please like and comment and subscribe. Thank you for watching the video.